language.
Yes, that's right. Okay. So it is my great pleasure to announce or introduce one of our own. So from the Pennsylvania Geological Survey, we have Chris Oest. And I'm not even going to tell you what he's going to talk about because he can take care of that. But for those of you who don't know Chris, he's been with us since he was a pup. So what was it, 2012? That's what Chris says. Michelle said 2011.
Was it 20? I couldn't remember.
Okay, we had Michelle.
2 years.
Yeah. Oh, yeah. So it was 2 years. So Michelle was also an intern. So Chris was an intern back in 2012, and he has lots of horror stories to talk about that. Oh, a show of hands. Who's been an intern here at the survey? Because Lindsay, you are. And okay. Spread the word. It's a great opportunity for students. We've already got our summer taken care of in terms of candidates. How about this for a rambling introduction? Okay, so all you know so far is that Chris was an intern, and I'm just going to leave it at that. So here we go. I'm going to turn it over to Chris, and let's give him a warm welcome.
Thank you, Al. Appreciate it. Let's see. What this guy? Bear with me for a second. There we go. Hey, I want to get rid of this guy. Okay, so yeah, let's get started. I have a lot to talk about. I have a lot of slides. I make no promises that this is going to be on time. I don't think I'm going to go too far over, but yeah, you've been warned. And with that in mind, before I get into anything related to any of the content in the stratigraphy, I would like to just go through a couple of acknowledgments. First and foremost, my co-author, Aaron Beerley, who has been extraordinarily helpful in this entire effort. Everything that I'm going to talk about tonight is related to our current state map project, which, as we'll get into, is located in Broad Top. And partnering with Aaron, for those of you who know him, he's extraordinarily knowledgeable, and that has been a massive resource for me. This work is funded by us, at least in part, and in part by the United States Geological Survey. It's a state map project. And I'm going to talk to a certain degree about some biostratigraphy. That's not me. I don't know anything about biostratigraphy. I don't know anything about micropaleontology, but we can pay people who do know these things. So Dr. Nick Hogenkamp from SUNY Binghamton and his private consultancy, Bedrock Earth History and Resource Organization, is our Conodont specialist. And Ellington Geological Services down in Houston is helping us with some paleontology work. So with that, I think we can finally get into this. So as the title implied, we're going to be talking about the Broad Top region, which a lot of people think of the coal field, and that's what's outlined here in red, but it's the namesake for a large structure, the Broad Top synclinorium, that goes throughout the entire valley and ridge. So the focus of this talk is, yes, it is Broad Top in respect to the coal field, but we're also focusing on the adjacent strata. And for those that aren't familiar, this isn't our first rodeo in Broad Top. This has been an ongoing project that started approximately in 2018. Cliff can correct me if I'm incorrect there, but I think 2018 is right. 2017. Okay. Up by a year. And the strategy here is to work from the eastern portion of the coal field to the western portion of the coal field, such that we can get a handle on the Pennsylvania stratigraphy in the structurally friendly part of the coal field before getting into the more structurally complex western portion of the coal field. So this project started with the mapping in the Saltillo Quadrangle by Cliff Dodge and Aaron Beerley. The second iteration is portions of the Entrican, Saxon, and Wells Tannery quadrangles, and that was It was also led by Cliff Dodge with assistance from Rosanna Bear and a good deal of work from a student mapping project, Tom Becker from University of Kentucky. Excuse me. And now we're in part 3 in the western part of the cold field. And because we're intersecting so many different quadrangles at this point, we're going to stop referring to it by the quads because it's just turning into this huge list of names. That's a mouthful. And we're just going to call it on top part 3, the finale. Okay. So now getting into some of the specifics here. So Broad Top is situated down here in south central Pennsylvania. It's in portions of Bedford, Fulton, Huntington counties. And our study area in particular, we have an arbitrary southern cutoff. It's just parallel with the previous study area. Obviously, we're picking up where the previous study left off. And then we're continuing the mapping to a stratigraphic cutoff. And basically what this is doing for us is creating a seamless corridor of mapping in this part of the world. So we've extended our study to the top of the Montongo Formation because that's where the next map picks up. So now we have this block of seamless mapping and it makes everything look really nice. People like when there aren't huge border or busts between different mapping areas. So in a nutshell, we have Middle Devonian through Pennsylvanian strata. It's dominantly clastic, although there are a few really thin but also really important carbonate intervals in this section. And it's what I've been referring to as structurally diverse. So basically from the Middle Devonian up until the Mississippian, it's pretty straightforward. We have beds that are dipping at like 45 degrees to the east. There's some minor faulting and folding, but it's nothing crazy. It's nothing to write home about. The Mississippian through the lower Pennsylvanian starts getting a little weird. And then the rest of the Pennsylvanian is an absolute yard sale. And we'll get into that a little bit later in the talk. In terms of previous work in the area, I don't want to say we're in untouched territory because we've been mapping geology in Pennsylvania for well over 100 years now. But it's been a while since we visited some of these rocks. So Gardner in 1913 with the 3rd Pennsylvania Geological Survey, that's the last comprehensive accounting of the coal field itself up until this work. And then that's basically it for the immediate Broad Top area. Along strike to the north, the USGS did some mapping through the 1920s, and then it finally got published in 1945 by Butts. And then all the way to the south along the Maryland border, USGS with Wallace DeWitt also did some bedrock mapping in sort of the same stratigraphic framework. There's also a handful of theses and dissertations that have been based out of the Broad Top area, but there really has not been an effort to do a comprehensive evaluation of the stratigraphy or the bedrock geology in this area. Last little bit of housekeeping before we get into the meat of this. Excuse me. As we go along, of this nice little strat column every time a formation is introduced. So this will keep you oriented stratigraphically. It'll be highlighted where we are in the section. So it's like the sing along at home bouncing ball type of idea. And then to the right of the column, I have these symbols. The thing that looks like a tooth represents a location or a zone in that particular part of the section where we collected samples for conidant analysis. And where we have these little triangular things, that represents a location or zone where we collected samples for paleontology analysis. If it has a red background, that's bad. We didn't get any results, or the results were very poor. And if it has a green background, that's good. We got some kind of result, and it was at least, there was at least enough material recovered to give us some sort of indication of age. Okay, so now we're at the base of the section. We're in the middle Devonian, and there's two names in here. So it's the top of the Mohentongo Formation, and we have the Tully, which a lot of people are probably familiar with. But there's this other name, Clearville, that you may or may not be familiar with, and there's probably a good reason for that. But we'll get into that. So the thin upper and lower carbonate intervals, that represents what we would consider the Tully facies in this part of the interval. Near the bottom of the Tully interval, or the Tully-Clearville interval, undivided, is this interesting lithology. It's an oolitic grainstone. It's loaded with fossils. In this case, there's this Favosites coral that's about the size of a football. In some places, the oolitic limestone only shows up as these little like lensy things, kind of sandwiched between wavy bedded pack stones or massive macritic limestones. And then the top of this interval is characterized by monotonous calcareous shale with big limestone nodules in it. And I shouldn't say big because sometimes they're about this size. Sometimes they're about the size of a walnut. Sometimes they kind of look like beds, but if you step back and you'll actually see them starting to taper. So they're actually just really big nodules. In between the two carbonate intervals is an interval that's dominated by clastic material. So this is mostly siltstone and shale, but there are some very fine-grained sandstones, and there's a lot of soft sediment deformation. So massive siltstone, soft sediment deformation, very little like bedded siltstone. We have this like rapid deposition signal that's coming through. And it also carries a lot of fossils that are similar to the carbonate intervals above and below. So what exactly is going on here? I don't have a great answer. And what we think is happening is that we're seeing the interfingering of the Tully type facies with the quote unquote Clearville type facies. As you travel to the south along this outcrop belt, so the approximate location of Broad Top is shown here with a little red line. As you move farther to the south, the carbonate interval completely disappears, and all you're left with is the clastics. That's what people have been referring to as the Clearville interval at the top of the Mohentongo Formation. So what we think we're seeing here is a wedge of this clastic material, which is shown here by this sort of dark gray, kind of intruding in between the dominantly calcareous shales and scattered limestones of what we would consider the Tully. So you might be asking yourself, well, isn't just the top part of the Mohentongo, aren't those limestones just the Tully? Well, we thought so too, but we collected a couple of conodont samples and they're essentially the same age. So we collected a sample from this that upper nodular limestone, and this is literally right below the black shale of the Burkett, which is stratigraphically above the Tully. And we also collected a sample from the oolitic limestone, which is all the way, that's the lowest carbonate interval that we observe in the field. And they both fall in this same conodont zone. And it's historically, it's been called the Varkas zone. It's since been subdivided into many finer scale zones. That's not really important for the story here. The Varkas zone is coeval with the Tully in New York. And so because we have the same age at this in this upper carbonate interval and the lower carbonate interval, that's why we're calling everything that's in this interval Tully with a tongue of Clearville, hence Tully Clearville undivided. We're still kind of ruminating on the name, so it's unfortunate that this is being recorded. That may not actually make it to the map. So yeah, check back in July and we'll see what we finally landed on. the last thing I'll point out with the conodonts before we move forward, this is probably not news for anybody that's familiar with the stratigraphy of New York. But the way that we present the Tully on our correlation diagram, it's basically being shown as continuous. There's no unconformity there. Well, we're missing the entire late gavation from the top of the Tully interval. And that's not a radical thing to say. It's been documented elsewhere before, but it is pretty cool to document it with some hard biostratigraphic evidence in Pennsylvania. And this unconformity actually also has a name. It's called the taconic unconformity, but not taconic, TAC, TAGH, etc. Pronounced the same, very confusing, very different unconformities. Okay. This mouse is driving me nuts. Above the Tully interval, excuse me, is this papery thin black shale. And there isn't really a whole lot more to say about it. It's pyritic in part, and it often the weathered surfaces have this really interesting iridescent sheen to it, and there's probably something related to the organic content. I'm not going to get into that, but it's this monotonous package of dark gray to black shale, and then on top of that, in the rest of the Horrell Formation, I skipped naming what we're actually talking about here, is even less exciting gray shale, and a lot of it. There's some really tiny fossils in it. All these little bumps on this is the bedding plane surface. I actually think it's this surface right here. Each of those little bumps is a tiny little brachiopods. So it's sparsely fossiliferous, but otherwise it's just this giant package of shale. This changes pretty abruptly moving up section. Aaron is standing next to a package of thick bedded siltstones, thick to medium bedded siltstones. They're massive. They're super hard. This is the base of the Borrelia Formation. And this package of siltstones actually holds up a minor ridge in the area. So this is a pretty easy contact to pick, even just with LiDAR. But you go out in the field, you're going from boring shale to big thick packages of sandstones. Even if you don't know what the formations are called, you're probably thinking, oh, something has changed here. But this doesn't really persist all that long. And this picture here, like if you needed to have a picture of the Borrelia Formation in a dictionary, that's what it would look like. It looks like a barcode when you kind of look at it on end. And it's because you have these evenly bedded siltstones and shales. The siltstones are pretty well jointed, so it really lends itself to that kind of like angular appearance. Every now and then you'll get one of these like very fine grained sandstone beds. It might be hard to see. It was pouring this day. It was not very conducive to taking photos, but this entire bedding plane surface is covered in ripples. So you get these coarsening upward packages of siltstones and shales into sandstones. And along with that lithological change, there's an entire suite of trace fossils in the Borrelia Formation. They're pretty interesting. If you're into trace fossils, Borrelia is a good formation to start poking around in. The lower third, so maybe 2/3 of the formation, you see a lot of these guys, Cruziana, this sort of double ridged thing with a line down the middle. And then you also see these things that kind of look like fingers. And I'm not 100% sure on the ID for this one, so don't quote me on this, but I think it's Paleozoic. Once you get up near the top, and let me just explain something about this picture quick because it's a little misleading. You're looking at the face of the bedding plane. The bedding plane is dipping steeply towards us. And to make it fit on the slide, I rotated it 90 degrees. But what you're looking at is a bedding plane surface. And each of these dark dots are scolitos burrows. You're just looking down on the top of them rather than seeing them in cross section where you see the typical tube shapes. And now, once you get into the very upper portion of the Bralier, and I'm saying that very deliberately, and there's a word crossed out here, and we'll get into that in the next slide. The upper portion of the Bralier looks, from a morphological standpoint, it looks very similar. We have these, again, couplets of different lithologies. This time, instead of it being siltstone and shale, well, it's very fine-grained sandstone and shale. You start to see fossils, including these coconite fossil hashes, and you also start to see a scattered quartz pebble from every now and then. You have to look pretty hard to find them. So basically what's happening is since the Burkett, we've been walking our way up out of the basin closer to the shoreline. And just as an aside, the term shear has very much fallen out of favor. This was proposed by Dennison in 1970, and it corresponded to this package of considerable sandstone above the Bralier Formation. So what is considerable sandstone? How much sandstone do you need for it to be considerable? I mean, I can see a single bed of sandstone and consider its presence, but the point being, the definition was pretty vague, number one. Number two, a state line was used as one of its cutoffs. So the shear formation does not exist in Virginia. It stops at West Virginia. It can't cross the state line. So not really a well-defined formation. It didn't really have a utility. So our colleagues at the USGS, Alan Pitts and Dan Doctor, have been working on revising this stratigraphy to aid in their goal of creating seamless mapping between states. So basically everything from the top of the Bralier to the first laterally persistent conglomeratic sandstone is now Bralier. And that does jive with the general depositional model. So you'd have the Horel Formation down here in the basin, the siltstone shale couplets at the edge of the slope, and then up in the pro-delta area, you'd have more sandstone. So this makes sense from a sedimentologic standpoint, and from a stratigraphic bookkeeping standpoint, it's a little bit simpler. The Four Knobs Formation is the next formation up. And this is basically just two prominent sandstone intervals with a little bit of shale and siltstone in between. I mentioned in the previous slide that first laterally persistent conglomeratic sandstone. To the south, it's called the Briery Gap Sandstone, but we have a local name from Charles Butts that was defined in 1918. And it's called the Allogrippus sandstone. It's this really coarse-grained sandstone. There's conglomerate, but it's also, there's some minor amount of interbedded fines. The pebbles are kind of flat, disc-shaped, or discoidal, however you want to describe them. And there's also a lot of these interference-type ripples. So really what we're seeing here is the first signal of shore-face deposition. We're getting material that's above fair weather wave base. We're getting a considerable amount of coarse material out into the basin. So we've gone a considerable distance out of the deeper part of the basin at this point. The upper sandstone interval is basically the same thing. It's much coarser, but that is really the only principal difference. You can see all these white dots on this joint face are all quartz pebbles, and you can see in this photo here, they get pretty big. That quartz pebble is probably about the size of my thumb. So now we're most certainly in upper shore face type territory, maybe middle shore face, or up in the swash zone on the beach. Above this is where things start to get a little bit weird. This is, was this dying? Yeah. Thank you, Al. So the upper part of the four knobs gets a little strange. There, you've got the kitchen sink basically in here. You've got brachipod shell hashes, plant fossil legs, interference and straight crested ripples, and grayish red hackly weathering mudstones that are interpreted as paleosols. So we're very much in this marine, non-marine transition zone, and trying to actually map this contact is pretty challenging. And what you have to do is not rely on a single piece of criteria. There's actually several things that end up coalescing, and it really is one of those contacts that you walk by and then you realize, oh, I haven't seen a brachipod in a while. But these are the criteria that we've been using. So the width of these bars here represents the relative abundance of these different features. So we're looking for the abundance of marine fossils, rippled sheet sandstone, so meaning that their geometry is planar and not lenticular. Heterolithic beds, so flazer bedding, lenticular bedding, things of that nature. The abundance of plant fossils, the presence of paleosols, and something that we relied on really heavily was the appearance of lenticular cross-bedded sandstones. So the signal that that's sending to us is that we're finally starting to see channelized flow that represents sediments that are being deposited by streams at the fringe of this marine, non-marine transition. So really, you can have like this zone where drawing a contact anywhere in this sort of area can make sense. And it's just it turns into an argument with your field partner about where you're going to end up with putting the contact. In the broad top area, this transitional zone is at least 400 feet thick. So arguably you could map this as your as its own entity. You can, that can just be based on your zone of confusion. Like where do we become sure that we're in continental rocks, and where we become sure that we're in marine rocks, and then everything else in between is just this transitional nightmare. But we just lump this into with the four knobs. Like I said, eventually you just start seeing so many features that are just consistent with terrestrial deposition, like big packages of grayish red mudstone, cross-bedded sandstones cutting into that grayish red mudstone, clay and filled root traces in those mudstones. Now you're pretty confident that you're in the next unit up, the Sherman Creek member of the Catskill Formation. And so that is a term that was defined in central Pennsylvania, basically in Perry County, but we feel confident that the lithologic signature that we're seeing in Broad Top is consistent with its original definition. And really what that boils down to is it's a mixture of about 50% mudstone, 50% sandstone. Whereas the Duncannon member is much sandier. So you can consider the Duncannon member to be like this upper sandy portion of the Catskill Formation. What you start seeing are these thick packages of sandstone. The scale here is 4 feet. So this is a pretty considerable thickness of sandstone. It's frequently cross-bedded, and very frequently there are these lags at the bottom of these sandstone packages that are made up of this calcareous, this calcareous type material. So this isn't just an academic exercise in mapping these two different units. The calcareous lags were shown to be host rock for uranium and copper in sort of the Williamsport area. Are they economic? Well, no, probably not, because they're these little lenticular things, but it is of note to map them separately. In addition to seeing these really thick packages of sandstones in the Duncannon member, If the conditions are right, you'll also see them associated with really thick packages of mudstone, but this is basically all we have in Broad Top. As soon as the outcrop stops, that's probably the mudstone. You can kind of see it poking through the vegetation here as the hammer for scale, but it doesn't really express itself very well in the outcrops in the Broad Top area. But if you do go elsewhere, this is a photo mosaic of the exposure on 322 outside of Port Matilda. Little orange dot here. That's me for scale. You can see above this red line, there's considerable more sticky outy beds. Well, those are all sandstones. So there's a marked difference in the sandstone content at a particular interval in the Catskill Formation. All right, so let's revisit a block diagram and kind of bring this back together again. So starting distally out into the basin, this is the Horrell Formation where we have the black briquette shale and the monotonous gray shales. This is just background sedimentation in the basin. You move up to the sort of the pro-delta area, and this is the siltstones and shales and some minor sandstones of the Bralier. These offshore bars and then the shore face, that's your Four Knobs Formation, and also including this, I guess we'll call it distal alluvial plain. And then the medial and I guess source proximal alluvial plain settings, that's captured in the Sherman Creek and Duncannon members of the Catskill Formation. So what we've done so far, we've just done this big march out of the basin and almost up to the Acadian source area. And now we're kind of going to turn around and go back the other way in the Rockwell Formation. This is a really interesting interval. It's pretty heterogeneous, and it's unfortunate that in that it is not very well exposed in our study area. But where we did see it, its base is typically characterized by a sandstone that's a little bit coarser than the Duncannon member sandstones. And interestingly enough, above that sandstone package, we have this dark gray shale interval. Now, this caused us some problems because we're a long strike from the Warriors Path section. If anybody's familiar with that, it's near Warriors Path State Park. So at first we thought, Aaron and I thought that we were looking at the Riddlesburg. But looking at our map, we're way in the wrong position for this to be the Mississippian Riddlesburg member of the Rockwell. So we collected samples for paleontology here, and luckily this is one of the samples that we were able to get some results from, and this is a Devonian-aged fossiliferous shale. So we have Devonian marine incursions starting, or at least tongues of those incursions as far to the east as the Broad Top area. What people typically think of when you hear Rockwell Formation is the diamictite. We didn't see the diamictite, and it's not entirely surprising. We're just outside of what Brzezinski and others have mapped as the western limit for the diamictite facies. But what we did see is this poorly sorted green sandstone with quartz pebble clasts and a lot of lithic clasts. So what we think this is the pebbly sandstone facies of Brzezinski and others. And this is just an associated facies to the diamictite that's interpreted as possibly being like outwash streams coming down off of the Acadian highlands. It's different markedly in its composition to all the other sandstones around it. It's very immature. So it does make sense that this is, possibly some sedimentologically immature glacial sediment that's getting washed into the system. Okay, and then above the rock, or I shouldn't say that. We're very uncertain about the lateral relationships of these different facies. Again, very poor exposure. The Riddlesburg this is the type area for the Riddlesburg shale. So this is a dark gray, silty shale. It's kind of poorly exposed. It's typically really pencil cleaved. So the outcrop's kind of poor, but if you dig through it enough, you'll start finding marine fossils. And this is known to be Mississippian in age. We submitted samples to see if we can pull spores out of it, and struck out. So we'll just have to take everybody's word for it. In two locations near the top of the Rockwell Formation, we had these really thick grayish red mudstones that are mottled with this kind of olive gray color. And that was kind of an interesting lithology. We didn't really see that anywhere else in the Rockwell. And in the both locations we saw it, it was kind of near the top. So this kind of, it begs the question, is there some sort of unconformity at the top of the Rockwell Formation that's forming a Paleozoic? I don't know. This we need a grad student to go out and do a detailed workup of this potential Paleozoic. All right, so we'll take a little bit of a breather here. We just went through a lot of stratigraphy in, well, 40 minutes, but that's pretty quick for the amount of stuff we covered. So we started in the Tully, which is represented by this sort of blue-gray bar. And basically what we walk through here is the entire sedimentary record of a pulse of tectonism associated with the Acadian orogeny. So Frank Ettinson from University of Kentucky has coined the phrase tectophase, and he asserts that we can see these pulses of orogenic activity that are associated with these more laterally persistent black shales in the basin. So we went from a stable carbonate platform, deep basin, gradually infilled, and then we're restarting our next pulse of the Acadian orogeny with this next package of sediments. The next package of sediments is a little bit less diverse. For this part of the section, we're firmly in alluvial territory. We're not going to all these diverse marine environments. We're just dealing with streams at this point. The first formation in this interval is the Burgoon. Excuse me. Burgoon is almost entirely gray sandstone that's intensely cross-bedded. There are some thin intervals of fines. I'm showing you pictures of two of the three intervals of fines that we observed in the field. These are also the two intervals where we collected these samples for paleontology, and both of them also struck out, including this interval, which had plant macrofossils in it, which was somewhat disappointing for us. The only other evidence of accumulation of organics in this interval are these really interesting, massive pyrite nodules that we see from time to time. So that's just kind of a neat thing to see. It could also be problematic. It's clearly not a good rock for aggregate. And you could potentially be dealing with acid rock drainage problems if you happen to run into enough of this. The Burgoon is also where the structural story starts to take a little bit of a turn. So I've got these two photos side by side, and scale bar here is about 4 feet. And I tried to simulate squinting and turning your head at the outcrop by putting this transparent gray over it. So if you look really closely, you can see that the beds are kind of curving towards this planar surface where the scale bar is. And then on the other side, you can make out bedding, but there's also cross bedding. So there's a lot of planar features that are starting to intersect each other, and it just turns into a little bit of a mess. This photo looks innocuous in and of itself, but you have a dip slope here. Just beyond this telephone pole, the beds are dipping into the hillside. So this is where we're starting to see more frequent faulting and more frequent folding in this part of the section. The Trough Creek interval is super cool. This is a really interesting carbonate interval at the base of the Mauch-Chunk Formation, and it's only observed in the southern portion of our study area. So we've only have like maybe half a dozen outcrops where we observe this species, and they're all in the Sherman Valley. In that main outcrop belt that trends northeast southwest, you don't see any of this. It's just completely absent until you get to Trough Creek State Park to the type section. Typically, the base of this interval is characterized by a massive micrite, and it usually has this really interesting fluted weathered texture to it on joint surfaces. Above that is usually a thin-bedded rippled limestone with some shaly partings. And then ultimately the top of the interval is this calcareous siltstone that is sometimes cross-bedded, other times it's just this massive, structureless calcareous siltstone. And this is actually more typical of what you observe of the Trough Creek. And it may even be controversial that I'm calling this clastic part of the interval Trough Creek and not restricting it to the limestone. But we feel that this is different enough from the overlying Mauch-Chunk that this should be included with the Trough Creek interval. And to drive that point home, this is what the rest of the Mauch-Chunk looks like. Cross-bedded sandstones, hackily weathering grayish-red mudstones. The mudstones can be calcareous, but it's not like the entire matrix is calcareous. There are nodules that are calcareous. So these are paleosols with soil carbonate in them. Okay, then next is the Pottsville Formation, dominantly sandstone, often cross-bedded, often covered in lichen. Does not outcrop that well, except for on the rim, the lower portion in contact with the Mauch-Chunk. There are some shales, and again, you can see the structure is starting to get a little weird on us. So the upper part of the Pottsville is notable when it is exposed. We're seeing these massive amalgamated sandstones. I guess that you could probably call this the Homewood interval. We all know that it's not really the same. It's not just one fluvial channel. It's just a sandy interval. Call it Homewood. Don't call it Homewood. There's a sandy interval at the top of the Pottsville in Broad Top. And just a quick summary here. Deposition of at least the Mauch-Chunk through the Pottsville. You have a kind of a quiet alluvial plain setting for the Mauch-Chunk Formation. That's why you have all those red beds and a lot of mudstone. And then the Pottsville Formation represents a more active system, more potentially a braided system, but we're also very distal compared to the Pottsville of Pottsville. So you don't actually ever see any of the classic like goose egg conglomerates of the anthracite region. This is more of a conglomeratic sandstone at best. Okay. This is where things start to take a little bit of a turn. So the last contact that we can actually map in the field is the Mauch-Chunk Pottsville contact. The remaining contacts in the Pennsylvania section, as some of you may be aware, are all defined on coal beds or other key bed surfaces. So first of all, I don't claim any credit in figuring all of this out. This is all of the work of Cliff Dodge over many years to establish the correlation between the main bituminous field and Broad Top. He graciously left this with me upon his retirement. So what we have in Broad Top for our contact surfaces, the base of the Allegheny is defined at the base of the Wood coal being equivalent to the Brookville coal of the bituminous field. The base of the Glenshaw Formation is defined as the base of the Phipps coal, which is equivalent to the Mahoning of the bituminous field. and then the base of the Castleman Formation, it's still equivalent to the top of the Ames Marine Zone. And we have demonstrated that the Ames Marine Zone is present in Broad Top. However, for reasons that will become apparent in the next couple of slides, we also treat the base of the North Point 1 coal as being essentially coincident with the top of the Ames. Is that actually true? Well, no, probably not. But this is one of the problems in mapping the Pennsylvania section in Broad Top. So this is just an assumption that we have to work with to get in the ballpark. Again, to drive this point home, this is the southwesternmost portion of the Broad Top coal field, and all these blue lines are tentatively sketched in fold axes. So these surfaces are really going all over the place. How do you know where you are in the section if this is what you're looking at? That's just a coal bed. If you're lucky, you have mining information to kind of clue you into this, but that's often not the case. And what we have found is most of the strip mines have been reclaimed in Broad Top. So this is actually the exposure that we're dealing with. There's not a coal bed exposed, and even if it was, it wouldn't matter because we didn't know what we were looking at. So we had to change our approach from a field-based approach to more of an office-based approach. And the QR code down in the bottom right, this is a shameless plug. That goes to a publication that we released about a year ago, and it's the digital elevation model for the basal surface of the Fulton coal. And that is, from that publication is what we derived a lot of our context for this interval from. So in order to construct this model, we took as many elevations from mind maps as we possibly could, digitized them in ArcMap, and made sure that they were corrected to modern datums and projected to the Fulton common datum using average intervals. We also fed structure contours into this model, and the things that look like dark, thick black lines, those are actually all these maroon points. There's just a lot of them. Those are crop line points that we converted to, or crop lines that we converted to points to interpolate elevations from. So we have all these data feeding into this model to create a common surface. But there's a caveat, and that is, I just found this quote from Bill Edmonds in the 1986 field conference. I was in the middle of putting all this together, and just, you see this kind of stuff, and you're like, oh, what are we doing? But with all this said, we made every effort, and I keep saying we, but most of this work was done by Cliff Dodge, made every effort to make sure that the coals that we were looking at on these mind maps were in the correct interval. So while we present this data as a surface, but it's more of a surface approximation. But with that being said, it did turn out reasonable. So we did capture the general structural trends of the coal field. You can see from this oblique view, we're looking along this axis here. And I think the most interesting thing about this digital elevation model is that in the structurally complex part of the coal field, where we have a lot of data, we can actually capture these mini whaleback things going on in the subsurface in Broad Top. And we really do think that these are real because where we see these, we have really good mind map control. So what we did from this full coal field model was spin off a couple of different models. But the first step was to do an erosion correction. So we have a DEM with elevations representing the base of the Fulton coal, and we have our surface DEM. And if you subtract those two, you're either going to get negative or positive values. The values are negative where the Fulton surface is greater than the ground surface. That means it's eroded, it's in the air, it's gone. Where the values are positive, it's in the subsurface. And then where the positive and negative values meet, in theory, that should be a crop line. And that's how this manifests for broadtop. And we used this approach and then projected up and down from the Fulton to the different contact defining coals to get approximate crop lines. Now they look decent at this scale, but when you actually start working with it, things really started to break down pretty quickly. So again, where the red and the yellow, I switched the colors on us. The yellow here represents strata that's been eroded. Red is now in the subsurface. That's my fault, but just bear with me. The interface between these two colors, if we're following the logic of this modeling approach, should be the crop line. Well, that looks completely ridiculous. And when you actually compare this model data to the mind map data and start drawing in structure contours and sketching in contacts based on elevations, this is actually the pattern that you come up with. In some cases, it actually did work fairly well. So if you look at this incline here, there's a big patch of red here. So we could expect there to be a little Castleman inlier in this incline. And based on the mind map data, that is probably accurate. You can see that the model works extraordinarily well. These are polygons from the Entrican Saxon Wells Tannery project, but like, what's the point of doing this modeling if you already have the contacts? So it's kind of a moot point, but at least a nice test of concept. All right, I'm running a little slow, but we're almost there. So buckle up. This is the last couple of slides here. I have a couple of slides with outcrop photos, but the bulk of the remainder of the talk is based on the broadtop reference core that we have here at the survey. So the Allegheny Formation, basically all we see in outcrop is the sandstone. There's some shaly intervals, but the outcrop is very much biased to the coarse fraction. We saw one exposure of a flint clay, and the only thing that we can say that's different about the Allegheny Formation from the underlying Pottsville Formation is there is a noticeable uptick in the amount of fossils. Outside of that, maybe the color's a little bit different, and there's a little bit more diversity in the types of finds that you're seeing, but this is not a contact that I would attempt to map based on field data. And part of the reason why we're starting to see more diverse lithologic assemblages is because we're in this deltaic environment. So what we're looking at here, the Woods Run Moraine Zone, and we sampled this because it looked really promising. There's all kinds of fossil material in here that's really encouraging when you're looking for microfossils. And what we pulled out of this was these guys, Streptonothotus firmus, not going to get the Latin entirely right, and S. gracilis and S. eleganthulus. Okay, so whatever. S. firmus and S. gracilis only overlap in one condensate zone, right here. And further, they only overlap in one cyclothem in the mid-continent, the Stanton cyclothem. Great. Well, we really nailed something. We got it narrowed down pretty far. Well, it's not in the right place. This Conodont zone is shown by Heckel and others to be equivalent to the next marine zone up, the Noble Marine Zone, which after a conversation with several former Geological Survey staff, they very much told me that this is a weird marine interval that does not really show up all that frequently. So we've got a little bit of a problem on our hands here. Part of that problem is the limited conodont data. So this correlation is based off of 2 sample localities from the Woods Run interval and only a sample from the Noble type section in Ohio. So we really don't know what the faunal distribution looks like in Pennsylvania in the Appalachian Basin. That and the fact that, I'll take Nick Hogenkamp's word for it, these are apparently evolutionary, very young looking conodonts. So what that could potentially mean for us is that S. firmus actually shows up much earlier in the Appalachian Basin than it does in Kansas. And what does that do for us? Well, that puts us in the next conodont zone down, and now everything is right in the world, and the Woods Run is correlating with the appropriate conodont zone. So this is all testable, but all very much outside of the scope of this project. And really, at this point, the lithologic correlations based on lithology, interval, what have you, are much stronger than the conodont data. It's just an interesting result, and hopefully we can pursue that in the future. Also got a lot of other bugs out of this interval, all kinds of gastropods, all kinds of ostracods, everybody's favorite bryozoan, Archimedes, fish teeth, and pelecypods. So what's interesting about this is the Woods Run marine zone, but we're also pretty far up depositional dip, so we're getting a very brackish signal out of this. Same story goes for the Ames marine zone. We get these brackish fauna. There's pelecypods and lingula-looking bracts, and there's also quite a lot of calcareous paleosols in the Glenshaw formation. So that points to some level of seasonality in this time period, and it's also pretty arid, which jives with the Glenshaw formation being relatively poor with respect to economic coals. Here's a photo of a fossiliferous shale. This could be from anywhere in this section. Outcrop was exceptionally poor in the Castleman interval, and I think that's to be expected because there was very little Castleman that's actually preserved in the Broadtop area. These plant fossils probably could tell you something about where you are in the stratigraphy if you had enough outcrops, but unfortunately, this was the only outcrop where we had really good plant fossils, so it didn't really tell us much of anything. Again, back to the core. We didn't get any conodonts out of the Castleman limestones, which, not surprising, they're either really nearshore brackish limestones, or we're talking about freshwater limestones at this point. So this is the Federal Hill interval, and this is kind of an intraclastic limestone. And the Wellersberg is an interesting complex of micritic and nodular limestones, and it's also interbedded with these really weird-looking, very calcareous paleosols. So it's a pretty thick interval of carbonate. So what we have going on here, a very poorly sketched in a shoreline. This is just for discussion purposes. During the deposition, the Allegheny Formation, we start seeing this, this embayment with moraine stuff out west and deltaic stuff around the fringes. That embayment expands into central Pennsylvania, and that's how we get these marine zones out into the Broadtop region, and then through the deposition of the Castleman and up into the younger Pennsylvanian and eventually the Permian strata. This embayment just totally disappears, and that's what, this is the Dunkard Basin. It's just collapsing upon itself during the later stages of the Allegheny orogeny. Okay, so all that. Here's the final summary. We went through 2 of the 3 Paleozoic orogenies. We have a pretty good sedimentary record of both of those events. We have one mass extinction event that doesn't manifest itself well in the sedimentary record in these sort of shoreline proximal environments, which is why I glossed over it, but it's in there. And we have these two significant climatic events. You have the late Devonian glaciation, then you have all the Pennsylvanian glaciations. So just to sum this up, this area is really a prime area for understanding this part of Earth's history. And even though some of the exposure wasn't really that great, if you look at enough of this stuff, you can kind of start to piece together the story that I'm telling here. And just to close, this is my contractually obligated plug for the PA Geode website. This is where you can get all of our publications if you're not familiar, or just tool around and look at the geology. All right. Thank you, everybody.
I know we're like a little past schedule. He did warn us. But if there's any questions we want to take care of right now, online, if you want to put anything in. Yeah, go ahead.
Is there active coal mining still occurring at Broad Top at this time?
Very little from what we observed. What would be a
Just in the eastern end, south of Robertsdale, close to the village of Wood, sort of in that area there. It's actually on that coal that I named, the wood coal, which is equivalent to the Brookville. And it's sort of a high ash, low vol bituminous coal, low in sulfur.
When did coal mining first start there?
There was mining back during the time of the first Pennsylvania survey. There were some little country bank mines. No way to really ship it because the railroads hadn't come in yet. So, say late 1830s, 1840s, there was some local mining. It really took off in the 1870s, post-Civil War. Some of the bigger mines started up in the 1870s.
Yeah, how big are those pyrite nodules in the Burgoon?
the ones that we had in that photo were, I don't know, the size of grapefruits or something like that.
Big, actually. Like if you broke them out, they would be like big.
Yeah, probably. I mean, you're right. You're only seeing that top.
No, it's not the statue at outcrop on public land. Too.
So yeah, more or less, yeah.
Oh, right.
Yep.
Oh.
He's going there.
Right away.
It's along Route 26, just outside of Riddlesburg.
Just outside of town.
Riddlesburg?
Riddlesburg.
Yes.
They would be carrying us.
Yeah.
I had another question. There were some significant unconformities that appeared on your stratigraphic column.
Yes.
Those were in the, was there some in the Devonian and in the Mississippian?
Yeah, so going.
Any information on those, like the time frames? The hiatus that created? I always found that interesting in stratigraphic.
So we can ballpark it for the Devonian unconformity with our Condon age. So we know that the upper part of the Givation age of the Devonian is missing. I don't know what that is in numeric values off the top of my head, but that there is a significant chunk of time in this area. And that also, there's a little bit of an assumption baked into that. We assume that the Burkett is being deposited in the earliest Permian. So there, we can get a ballpark on that age. We didn't get any meaningful biostratigraphic data out of either the sub-Mach chunk or the Miss Penn unconformity. We know that is a fairly substantial gap in time. And if you go back to the YouTube recording and look at my strat column, there's an entire period of time missing in the latest Mississippi between the Pottsville and Mach chunk. So there is substantial time that's missing there. we were hoping to kind of firm up that unconformity between the Burgoon and the Mont Chunk, but we didn't get any polynomorphs to support that. What I got.
All right, well, thanks, Chris. We can hang around?
Or,
Oh, okay. You can't say no.
sorry, the diamond you found in the Rockwell, is it correlative to the Spectacov formation?
Yeah, the Rockwell is correlative to the Spectacov. We actually did not see the diamectite.
Right.
Unfortunately, that's a really interesting interval. I've seen it in West Virginia before, and it's really wild when you see it. But yes, that is the same diamectite.
Okay, because we're over time, I do want to conclude this meeting. For those of you here in attendance, please sign in to get your PDH credits. I'm going to send out the certificates this weekend. Let me know if you don't get it or you think you should have. I mean, that happens sometimes. It doesn't, things happen. And next month, we're going to be taking a tour of Antarctica. So that should be cool. All right, meeting adjourned. See you next week. Next month.